Hello friends, in today's question, the total number of turns and cross-sectional area in a solenoid is fixed. However, its length L is varied by adjusting the separation between the windings. The inductance of the solenoid will be proportional to. So in this case, we are supposed to find out how the inductance of solenoid will vary if the separation between the windings is changed. Or we can say the length of the total winding length is being changed. So in this case, we are going to start with the formula for the inductance, and we can say that inductance L prime is given by phi is equal to L prime multiplied by I, where L prime is the inductance of the coil and I is the current. And the flux associated with the coil can be also written in another format. You can say that flux phi associated with the coil, it can be written as phi is equal to N B A, where N is the number of turns in the solenoid, number of turns in solenoid, B is the magnetic field, and A is the cross-sectional area of cross-section. So we can equate these two equations and we can say that our, first of all, let us define B our. So magnetic field B, this can be written as mu Ni and we can write our area as pi r square. In this case, our mu is the permittivity of the free space, or rather we can say mu naught. Mu naught is the permittivity of free space small n is the number of turns per unit length. Number of turns per unit length, and I we already know is the current. And for the area, this r is the radius. Therefore, if we substitute all these values, we can write that our L prime yeah, so we can say that, let us call this as equation number 1, equation number 2, 3, and forgot this is 1, and this is our equation number 2, 3 and 4. So using equation 1, 2 and 1, 2, 3 and 4, using equation 1, 2, 3 and 4, we can write that our L prime I will be equal to NBA. From here we can write our L prime will be equal to NBA divided by I, and further we substitute value of magnetic field and area, and we can write that our L prime will be equal to n mu naught small n and I pi r square divided by I. Here I cancel with I. So we get this as n mu naught n, and here we have pi r square, and small n we already have written or defined rather number of turns per unit length. So this can be written as that small n will be equal to capital N divided by L. So therefore we can say, or in this case let us assume that the length is represented as small l, not capital L, to make it differentiate from the inductance value L. Therefore we can write that our L prime will be equal to, we get this n mu naught capital N pi r square upon L, and here this L is the length of solenoid. So this can be written as our n square mu naught pi r square divided by L. So therefore we can say that our inductance L prime is inversely proportional to length L. So the options that are given to us, option number A is the correct option. Option A is correct. So this completes the question. Thank you.